Hey guys, welcome. So today what we're going to be going over is ways to derive functions. So when the problem gives us is we have here c is equal to the derivative with respect to x of the natural log of x squared plus 2. Now when I see a function inside a function, I know that's a compound function, and what makes it really convenient is if we use what's called the chain rule. And what the chain rule states is if I'm being asked to take the derivative of a compound function, what's going to make life a little less complex is if I substitute in my u, or a variable u, into where the inner function is. So for this, I'm going to let my u equal my g of x term here. And so when I then go and do the chain rule, I'm being asked to then do the derivative with respect to u, because I'm plugging in the u here. I know this looks like a smiley face. This is a u. That looks even more like a smiley face now. Anyway, so now we have the f of u, and then I'm multiplying it by the inner function here, which is then going to be my du, but now I'm taking it with respect to x. When I go and plug in the u value into this function, I'm going to get the derivative f of u with respect to u multiplied by the derivative with respect to g of x of g of x. And this makes things less complicated when we are dealing with a compound or a compound function. And there's ways that we can check it. So let's just go ahead and test this out, where if I'm being asked to do this, so the derivative with respect to x of f of x of g of x, and I'm still going to let my u equal my g of x here, and I'm going to have the derivative with respect to u, f of u, not to be confused with fu there, but times that by the derivative with respect to u, or derivative with respect to x of u, and what we can do is cancel these out, and then we're left with the derivative with respect to u of f of u. Sorry, this is because these canceled out and we're multiplying straight across, then we get the derivative with respect to x of f of u. And then when we plug back in to the equation, we get our original function back. Just like that. So when we go and do this in our case here, we see that I have an inner function here, and I'm going to let this equal my u. Another smiley face there, I know. So we're going to let u equal my x squared plus 2. And then we're going to apply the chain rule here. So I'm then going to be asked the derivative with respect to u here. Apologize, I'm trying to write an x there. I'm getting a little too ahead of myself. Derivative with respect to u of the natural log of u multiplied by the derivative with respect to x of the inner function u. And in our case, it is the x squared plus 2. And so we're going to then go one step further and then plug in for the u term in the second derivation. So with the derivative with respect to x of x squared plus 2. Now the last thing to do is just take the derivative of it, where now we get the derivative of the natural log is 1 over u, and then we're multiplying that by the derivative of the inner function here, and we're going to use the power rule to get x, or 2x, when we take the derivative of x squared plus 2. We're going to go back up here now. And from here, what we're going to get is 2x over u. Well, I've got an x and a u here, so I need to then plug back in my substitution value. So I'm going to then plug in the x squared plus 2. And so I get 2x all over my x squared plus 2 for the derivative of our compound function here. So to go back over, we want to make sure to substitute in to make the problem less complex. We have a question. Go ahead, Jenna.
How did you know what the natural log derivative was? And then also, why did you use the chain rule when it comes to using the natural log of x to the power of 2 plus 2?
So there's two questions I'm hearing here. So what is the derivative of the natural log? I'm hearing right? That's the correct question. And then why would I use that for the chain rule? So when I go to my derivative tables, this is one of the identities that we have, where we have the natural log of a function inside is going to be 1 over the function or whatever is being multiplied inside by that. Now when I have, the next question is why would I use the chain rule? That's because I have the function natural log and then another function x squared plus 2 inside of it. And whenever you have a compound function, you have to use the chain rule.